Welcome back on SpaceInfo. Today we are going to talk about a red dot in the sky, our target for the future, planet Mars. Named after the ancient Romans' god of war, Mars is the outermost of the terrestrial planets. Indeed, as you may know, the solar system can be divided in two circular regions. The innermost, with the Sun in its center, up to Mars, and the outermost, concentric with the other, up to the border of the solar system itself. By the way, do you know how the borders of the solar systems are defined? Mars is actually smaller than our home planet. The diameter is half the one of the Earth. Since when it began to be observed from Earth, Mars resembled to be a reddish disk with dark spots and lighter polar caps. It is indeed in these regions that we are searching for water ice, and it is even suspected that in the past vegetation used to grow here. The polar caps change their color together with the Martian seasons, which enhances the suggestion that they might be composed of ice. In the same way, darker areas were suspected to be covered in vegetation. At the end of the 19th century, an Italian astronomer, Giovanni Schiaparelli, attributed darker swirling regions on the surface to the presence of canals. However, nowadays we know the canals were only an illusion due to an optical illusion. Humans had to wait until the mission of Mariner 4 in 1965, which spread some light on the biggest question of the last times: is there any life on Mars? Though, the answer was no. The rotation axis of Mars is tilted 25 degrees to the ecliptic, about the same amount as the Earth's axis. A Martian day is only half an hour longer than a terrestrial day. Mars' orbit is significantly elliptical, resulting in temperature variations of about 30 degrees Celsius between the aphelion and perihelion, which has a major influence on the climate. Indeed, huge dust storms are occasionally seen on Mars. They usually occur when Mars is at its perihelion and the heating of the surface originates a large temperature difference, which is converted into a large difference in pressure that causes strong winds. When this happens, the heat convection that is generated by the air masses moving over the surface causes a major transfer of heat and can rise wind speeds up to 400 kilometers per hour. The atmosphere of Mars is mainly composed of carbon dioxide, almost completely 95%. It contains only 2% nitrogen and 0.1 to 0.4% oxygen. Moreover, it is very dry. If all the moisture were condensed on the surface, the water layer would be thinner than 0.1 millimeters. The air pressure is almost 1/100th of the Earth's. We know that a part of the atmosphere has already dissolved into space, but it is likely that Mars never had a really thick atmosphere. It is known that perhaps only the very first form of atmosphere of this planet was similar to the one of our home planet, but with time, the majority of carbon dioxide formed carbonate rocks. A difference with Earth is the fact that no tectonic movement is present here, therefore no rock recycling is present. As a consequence, all the carbonate which formed those rocks is never given back into the atmosphere, supporting the greenhouse effect, which is almost insignificant here. Another consequence of this is that no active volcano has ever been discovered. The latest activity of this type has perhaps happened about 100 million years ago. Nonetheless, the southern hemisphere is marked by craters, on the bottom of which the original surface is still visible. Some of them can be attributable to impacts with celestial bodies coming from deep space, and the largest, Hellas and Argyre, are more than 2,000 kilometers in diameter. On the other hand, in the northern hemisphere you could find a lot of lava basins and volcanoes, and we know that the surface is geologically younger than in the southern hemisphere. The largest volcano, Olympus Mons, extends more than 20 kilometers above the terrain, and the diameter at the bottom is more than 600 kilometers. Even though Schiaparelli was wrong about canals, past orbiting spacecraft unveiled the presence of ancient rivers, now completely dried, which suggests the presence of liquid water all over the surface. Nowadays, temperature and pressure on Mars are too low for liquid water to exist. The mean temperature is now below -50 degrees Celsius, and, on a warm summer day, the temperature can rise close to zero near the equator. The majority of the water left gathered into permafrost buried kilometers below the surface and in the polar caps. The theory was confirmed in 2002, when the Mars Odyssey spacecraft detected a large supply of water ice of a wide area near the South Pole. Also, due to the absence of seismic activity, the interior of Mars is not well known. It is thought that Mars has a dense core, about 1,700 kilometers in radius, a molten rocky mantle which is denser than the Earth's mantle and a thin crust. The crust should be 80 kilometers thick in the southern hemisphere but only about 35 kilometers thick in the northern one. The low mean density with respect to the other terrestrial planets may indicate that iron should be combined with sulfur inside the core. The low density of the core, combined with its low percentage in iron and its low to zero rotational speed, support the weakness of the magnetic field of the planet, as the Mars Global Surveyor confirmed in 1997. Looking outside the thin atmosphere, Mars has two moons, Phobos and Deimos. They are very small if compared to Earth's moon, and their rotational period around the planet is consequently lower. Phobos needs less than 8 hours for a complete orbit. Due to their small mass and their surface, covered in craters, it is common opinion that their origin is from deep space and they were asteroids captured by the Martian gravity field. Next time we will get out of the terrestrial planets and will approach the outer part of the solar system. If you liked our journey so far, share SpaceInfo with your friends and don't forget to subscribe to our YouTube channel.